Okay, so these are the notes for 4.2. I am going to be gone. Obviously, that's why you're doing this without me there. But today we're going to talk about how to deal with OR probabilities and dealing with what's called mutually exclusive events and things that are not mutually exclusive. So when we talk about mutually exclusive events, there are two things that can't happen at the same time. So if I flip a coin, I can't have heads and tails. It's either heads or it's tails. There's no way to have both. Rolling a die and asking for an even or an odd. Those are mutually exclusive. When things are mutually exclusive, if I want the probability of one or the other, okay, whoops, go back over here to draw. Okay, there we go. When I want to deal with the probability of one thing or the other happening, okay, that's where we got this probability of A or B. If they're mutually exclusive, all we have to do is add the probability of the first event plus the probability of the second event, and we get our probability of having one or the other. So heads is 50%, tails is 50%, so the probability of getting heads or tails on a coin is 100%. I'm going to get one or the other, and if both are acceptable, then I can add them together. Probability of A or B when it's not mutually exclusive. So non-mutually exclusive means that there's something shared between the two options. So this example that we have down here, if we're rolling a die and we want the probability of getting an odd number, but also or getting a number less than 4, it's possible that there's an event that would do both, be odd and less than 4, like 1 or 3. Those are examples that fit both descriptions, and so that would not be mutually exclusive. They're what's called compatible. Okay, so if we look at these examples, determine which ones are mutually exclusive and which are not. If a single die is rolled, getting an odd number and getting an even number, that would be an example of mutually exclusive. You cannot have both. Getting a 3 and getting an odd number. Getting a 3 and getting an odd number can overlap. So this would be not mutually exclusive because the 3 on the one hand matches the idea of odd on the other. Getting an odd number and a number less than 4. 1, 2, 3 are less than 4, and odd numbers would be 1, 3, and 5. And since there's some shared values between the two, we say it's not mutually exclusive. Getting a number greater than 4 and getting a number less than 4. You can't be greater than 4 and less than 4 at the same time, so we would say this is mutually exclusive. Now when we go to do percentages, okay, and probabilities, probabilities, so we have corporate research and development centers for 3 local companies have the following number of employees: U.S. Steel, Alcoa, and Bayer Material Science. If a research employee is selected at random, find the probability that the employee is employed by U.S. Steel or Alcoa. So this would be the probability of U.S. Steel plus the probability of Alcoa. Now, is there any overlap, or are these mutually exclusive? A research and development person is not going to work for both of these companies, and so these would be considered mutually exclusive. So there's no subtraction required. I can just take these probabilities the way they are. Now to get the probability for U.S. Steel, it'd be 110 out of the sum of all those. Well, 750 and 250 is 1,000, so that'd be 11. So, sorry, 1,110. There we go. All right, and the probability of Alcoa would be 750 out of that same 1110. Grab our calculator and add those together. We got 110 divided by 1,110 plus 750 divided by 1,110. And we end up with a 0.775. So we'll go 0.775 would be my probability, or 77.5% of the time. We would expect that to happen. Now, when we're dealing with non-mutually exclusive, it means there are some overlaps. We're going to have to subtract the overlap to avoid double counting the same people. So let's fill this chart out. In a hospital unit, there are 8 nurses, so my total nurses would be 8, and 5 physicians. Okay, 7 nurses and 3 physicians are female. So 7 nurses and 3 physicians, meaning that there's 1 male nurse and 2 male physicians. If a staff person is selected, find the probability that the subject is a nurse or female. So probability of a nurse plus probability of a female. Okay, to add the nurses, add the females, but I have to subtract the probability that someone is a nurse and a female, because they will have been counted in the nurse pile and in the female pile, so that person or people have been counted twice. So probability of being a nurse would be total nurses is 8 out of 13 total people, plus a female. Well, the female total, if I look at my female total, is 10 out of 13. Okay, well, if you look right now, that gives me 18 out of 13. That's a problem. So I'm going to have to subtract the people that I've double counted. This would be the people who are both a nurse and a female, and that would be my 7. So I'm going to minus 7 out of 13. That would give me 11 out of 13. This would mean there are only 2 people who are neither female or a nurse. So we'd be looking for male physicians, and sure enough, that's 2. So I get 11 out of 13 as my probability. All right, so that's the idea of mutually exclusive and non-mutually exclusive and doing or probabilities. All right, good luck, and we'll see you when I get back.